How do you find angle measures in and around circles? This is for section 12-4 out of your textbooks. And we're gonna split this into two videos. This one is gonna talk about angle measurements, and then the next video is gonna talk about segment lengths. Okay, here's a reminder of how your notes should be set up to take notes from this video. This is video title 1. You do have a video title 2, which is next, and there's no video title 3. And once you've watched all videos, you then will create your summary at the very end. Let's review vocabulary. Let's review the vocabulary term secant. So remember, secant is a line that intersects a circle at 2 points. And you can also split this line into a ray or a segment. If I did, this is A and this is B right here, right? So if I said, okay, A to B is a ray, you can do that. And you can also say, okay, let's look at just the AB segment, the secant segment, which is here. And once you break it down to a segment, it becomes a chord within a circle. Okay, so here are two huge theorems that you'll need for the angle measurements. And let's see what they are telling us. Why don't you go ahead and make sure you write everything down from the screen. And then when you're ready to follow along with me, go ahead and resume the video. So this is all about angle measures. Theorem 1211 out of your textbook says the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arc. So what does that mean? If you add this arc plus this arc and then divide it by 2, you can get this angle measurement here. This is not a central angle. This is not an inscribed angle. Remember, central angle would be at the very center of the circle and inscribed would be at one of the edge of the circles. This is just an angle within a circle. Then you have the next theorem. The measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arc. So let's take a look here. If you have this intercepted arc, which is the minor arc and then this major arc here, you will take a half of the difference. So you subtract the major by the minor, and you'll take half of that. Subtract major from minor, take half of that, subtract major from minor, half of that, and that will give you this external angle, this angle outside of a circle, okay? So when it's on the inside, you add the two arcs divided by 2. When it's on the outside, the angle that you're looking for, you subtract the arcs and divide it by 2. So this one's adding, this one is the difference. Now let's practice two examples. So remember when you're trying to find the angle on the inside, you add and divide it by 2. When the angle's on the outside, you subtract major from minor and divide that by 2. So let's take a look. Here is the first one where we're going to have the sum. Oops, I did not mean to do that. Let me erase that. Okay. And then you have another example where you have where this ends up being the difference because you're looking for that. You're using this angle on the outside. So in this case, you're looking for this angle. This one, they gave you the angle. You're just looking for this arc, but you're going to use those formulas that we discussed. So I want you to practice them on your own first. And then when you're ready to check your work, go ahead and resume the video, but pause it right now, write everything down and practice them using the theorems you just wrote down. And I'll assume that you did practice. So let's look at the answers and let's discuss them. Okay, for the first example, remember you're going to add the two arcs and then divide that by 2. So we got x to be 68 degrees. And on this one, it's a little bit different. You're not looking for the 20 degrees, this angle on the outside. You're actually given that. So when given, you just plug the same information into the formula. So 20 goes here. You're taking half of the major arc minus the minor arc. So you multiply by 2 to both sides to get 40, subtract 95, then make sure you transfer over the negative because you can have negative degrees, and z ends up being 55 degrees. Hopefully you got those correct, and if not, then you should have some questions to ask me in class tomorrow. Okay, here are two other examples for you to practice, and I want you to think about which one are you going to use. Are you going to use the sum or are you going to use difference? So go ahead and take a look at the theorems. Go ahead and practice these examples. And then when you're ready to see the answers, go ahead and resume and we'll discuss what the answers are. Okay, here are the answers. Hopefully you got these correct. So let's take a look for this one. Since I'm looking at this angle on the outside, I know I got to do difference, divide by 2. So I'm going to do the major arc, which is W, which is what you're looking for, subtracted by the minor arc, 110. We're going to take half of that. Then we multiply both sides by 2, solve for W, and get W is 250 degrees. You could check it too to make sure that it works. You should be able to subtract these two, divide it by 2, and get the 70. And then for number 4, we are looking for the outside angle. So we'll just set up our equation. It's major minus minor, and divide that by 2. So you get y equals 40 degrees. Let's take a look at a real world example. Okay, here's a real world example for you to practice. And then I'd like you to bring your notes to class and all the work you've done. So you focus your camera on a fountain. Okay, so here's your camera and you're focusing on this large fountain. Your camera is at the vertex of the angle formed by tangents to the fountain. So this is your angle right here. You estimate that this angle is about 40 degrees. What is the measurement of the arc of the circular basin of the fountain that will be in the photograph? So then what is the measurement of this arc here, which is x? Go ahead and use the theorems to help you and bring any questions you have to class. How do you find angle measures in and around circles? We went ahead and discussed some methods on how to get those using theorems and some formulas that you could set up. I'd like you to bring any questions that you have to class, but remember that for your summary, you should answer this question by looking at the theorems and the examples given in the video.